You felt it. Every year, the calendar seems to cycle through faster. Summers that felt like eternities when you were 8 now blink past in what feels like weeks. It's an unsettling sensation driven entirely by mathematics. Our perception of time relies heavily on the scale of history we've already accumulated. Psychologists call this proportional time. At age 5, a single year represents a massive 20% of your entire lived experience. By the time you hit 50, that same 365 days shrinks to a mere 2% of your life. As those fractions get smaller, time dilates. The brain measures new experiences against a constantly expanding denominator, causing life to slip by faster and faster. We can't stop the calendar from moving, but this accelerating clock only becomes a true threat when it collides with a biological problem. In 1880, a German psychologist named Hermann Ebbinghaus sat in an austere room with a stopwatch. He memorized thousands of nonsense syllables, random consonants and vowels, without any meaning, to measure the exact rate at which a human being loses a memory. This chart shows the result, the Ebbinghaus forgetting curve. The math is brutal. Within a single hour of learning something new, the brain naturally discards nearly 50% of the information. By day 2, the drop-off is catastrophic. The brain acts as an aggressively efficient landlord. It actively evicts data that you don't frequently review, treating unaccessed memories as wasted cognitive space. So we face two forces at once. The fractions of our life are accelerating proportionally, and the details of that life are decaying exponentially. Without an intervention, the inner life we build simply vanishes into the dark. Modern cognitive psychologists have looked closely at how we try to fight off this decay. The intuitive methods most of us use, cramming the night before a test or repeatedly rereading a textbook, actually fail entirely. We can see why in this visualization, comparing two distinct properties of memory. The first meter tracks retrieval strength, how easily you can recall a fact right now. The second tracks storage strength, how permanently that data is embedded. Cramming spikes retrieval strength immediately, but it drains just as fast. Researchers Robert and Elizabeth Bjork coined a framework for this called desirable difficulties. If a study method feels easy and fluent, you're likely experiencing an illusion of competence. Storage strength only actually increases when retrieval is forced to work against friction and resistance. To flatten the curve of forgetting, we have to abandon comfortable review. We have to engineer productive, deliberate struggle. The first tool for this is visible in this expanded chart of the forgetting curve, known as spaced repetition. By spreading out our review sessions over increasing intervals, 1 day, then 3 days, then a week, we interrupt the decay precisely when a memory is about to be lost. Each review forces the brain to reach back into the dark, resetting the line and making the slope of decay noticeably flatter. Next, we apply interleaving. Instead of practicing one skill over and over until it feels easy, you scramble related subjects unpredictably. This sequence forces the brain to constantly switch contexts, creating a state of discriminative contrast. The friction of asking not just how to solve a problem, but which approach to use, deepens the memory trace. Then there is elaborative interrogation. Take a date like December 7th, 1941. Passive reading accepts the timeline. Active elaboration demands you ask why Japan chose that specific Sunday morning to attack Pearl Harbor. Forcing a piece of isolated data to answer a why question aggressively anchors it into your existing web of knowledge. Finally, there is the Feynman technique. You take a complex concept and explain it aloud in language simple enough for a child. Stripping away the jargon forces you to confront the exact boundaries of your own understanding, turning passive consumption into active, generative mastery. These strategies, spacing, interleaving, elaborating, and self-explaining, operate far above the level of study hacks. They shift focus from immediate recall to long-term storage, providing the cognitive tools needed to build memory traces that can withstand the pressure of time. The mathematics of proportional time will always govern how we experience the calendar. At 50, a year will still be a tiny 2% of your life. We cannot stop the clock from accelerating, but by applying these desirable difficulties to our lived experiences, we improve the odds of retention. We can intervene in the withdrawal of memory, keeping more of those life fractions vivid and accessible. Ebbinghaus's graph from 1880 is a blueprint for that intervention. By mapping the exact rate of decay, he identified the precise window where effortful retrieval can stabilize a thought before it vanishes. Keeping your inner life rich requires the discipline of timing. It requires the willingness to step into the friction, to reach back for a memory at the exact moment it threatens to slip away. Everything fades, the math guarantees it. But with the architecture of effort, we can look at the exponential decay of our own lives and say, "Not yet. I remember."